Welcome everyone. Today we're starting 7.5. This will be 2 days worth, so 7.5a will be today. We are solving special types of linear systems today. So the first thing we need to do is we need to determine if these lines are parallel. So if we take a look at this first line, line A, we can find parallel lines by counting the rise over the run. So I can go up 1, up 2. So for line A, I make a line with 2 arrows on top to say line A. Line A slope is 2 over 1, 2. So 2 over 2, which would actually just give us a slope of 1. Line B, we're going up 1, 2. So line B has a slope of 2 over 1, 2, 3. And then line C has a slope of 1, 2. And over 1, 2, 3. So we determine if these lines are parallel if they have the same slope. So parallel, remember, means the same slope. So I see that B and C both have the slope of 2 over 3. So line B is parallel with line C. If we go over here, we can start with line A. So this is going down, so I know my line A is going to be negative. So negative 1, 2. And over 1, 2, 3, 4. Or negative 1/2. Line B that goes down negative 1, 2, 3 and a half over 1, 2, 3, 4, 5. So down negative 3.5 over 5. And then line C has a slope of negative 1 over 1, 2. So negative 1/2. So I see that A and C are the same. That means that line A is parallel with line C. Now, just like with any one that we've been dealing with here, there are 3 possible solutions. One solution is to have different slopes. So if we had 2 over 3 and 1 over 2, that would just be one solution. They would intersect at a point, and that would be the one solution. No solution means the lines are parallel or have the same slope. So 1/2 and 1/2, that means their lines are going next to each other. They never cross. There's no solution. Infinitely many solutions is the same line, so the same slope and the same y-intercept. So like 1/2 x plus 3 and 1/2 x plus 3, that would just be the same line. So infinitely many solutions, another way we can write that then is just IMS, infinitely many solutions. Just an easier way to say that. So let's try this. So we need to solve this system by graphing. We have 3x plus 2y equals 10. We need to get y by itself to graph it. So I'm going to subtract 3x and 2y equals negative 3x plus 10. Divide by 2, and y equals a negative 3.5x plus 5. So I know I begin at 5. 1, 2, 3, 4, 5. I'm going negative 3, 1, 2, 3, and over 2. 1, 2, 3, and over 2. Up 1, 2, 3, and over 2. So we could create a line from this if we go a couple more here. So there's our first line. Our second line is 3x plus 2y equals 2. We subtract 3x. We get 2y equals negative 3x plus 2. So y equals a negative 3/2 x plus 1. That begins at 1, goes down negative 1, 2, 3, and over 2. Down negative 1, 2, 3, and over 2. 1, 2, 3, over 2. Go up 1, 2, 3, and over 2. 1, 2, 3, over 2. So, if we made this line, we need to figure out if this is a one solution, no solution, or infinitely many solutions. Well, it doesn't have different slopes, so it's not one solution. It does have the same slope, so it could be, or is parallel. So let's see, does it have the same slope and the same y-intercept? No, one is 1 and one is 5, so we know that this is no solution. These lines are parallel. So, because they have the same slope, so this is no solution. There's nowhere where the lines cross. Our next problem, if we add 3x here, we can solve this already. So we get y equals 3x plus 2. So we start at 2 and go 3 over 1, up 3, 1, 2, 3, and over 1. 1, 2, 3, and over 1. So we can draw our line then. Then for our second equation, negative 6x plus 2y equals negative 2. You got to move the 6x over. And we get 2y equals 6x minus 2. We divide by 2. We get y equals 3x minus 1. So this begins at negative 1, goes up 3 and over 1, up 3 and over 1. So this gets really close to the other line, but still doesn't cross it because we have the same slope. Again, if we have the same slope, it's no solution because they're parallel. Alright, our next one, we have y equals 1/2 x plus 2. That's already solved for y, so I know I can immediately solve or graph that. So I begin at 2. We go up 1 over 2. And if we continued, we'd have a line like this. So if we made that line there, now our second problem is x minus 2y equals a negative 4. So I'm going to move the x over by subtracting. So we get negative 2y equals a negative 1x minus 4. Divide by negative 2. And we get y equals now a positive 1/2 x. And negative 4 divided by negative 2 gives us a positive 2. So we begin this line at 2. Then we go up 1 over 2, up 1 over 2, and we're on the same line. All of these points line up with all the other points we had for the other equation. So what this is, it has the same slope and the same y-intercept. This is infinitely many solutions. So all of the solutions on this line would work because they're the same line. This one we have to solve using elimination or substitution. If I look and see 3x and x and negative 2y and 2y, I know that immediately I can eliminate the y's because I have a negative 2y and a positive 2y. If we add these two together, 3x plus x gives us 4x. Negative 2y plus 2y gives us 0, it eliminates. And 24 plus 8 equals 32. If we divide by 4, we get x equals 8. Then putting that 8 into our equation, we have 8 plus 2y equals 8. We subtract the 8 then. Eight minus 8 is 0, so we get 2y equals 0. If I divide by 2, that's possible. We can divide 0 by 2. So y equals 0. Our solution is 8, 0. So this has one solution. Second problem has 3x minus 6x and 2y minus 4y equals 4. 4 equals negative 8. Sorry. So what I know that I can do is I can multiply this top part by 2, and that would give me enough to eliminate some. 2 times 3 is 6x, 2 times 2 is 4y, and 2 times 4 is 8. So if I notice now, I can eliminate both of these. I can eliminate both x and y if I add them. Negative 6x plus 6x gives me 0. Negative 4y plus 4y gives me 0. Negative 8 plus 8 gives me 0. Everything equals 0. what that means is that we have infinitely many solutions. 0 does equal 0, that's true. So infinitely many solutions would be the answer to this problem. Again, we're using substitution or elimination here. What I see is that I have 3x and x, y, and 1/3 y, 4 and 2, but we're only worried about the x's and the y's. I'm trying to eliminate, so I think eliminating is the easiest. So I'm going to eliminate by multiplying this by 3. So we get 3x plus y equals 4, and 3x plus y equals 6. Then if I subtract these two equations, 3x minus 3x gives me 0. Y minus y also gives me 0. So we have 0 on this side. 4 minus 6 gives us a negative 2. Well, that's false. 0 does not equal negative 2. So we know that this is no solution. Last problem, we got to solve this by graphing. If we move this 2x over, I'm going to do that one first because it's on the bottom and there's some room. So we get y equals 2x minus 4. Then if we take the top equation, 2x minus y equals 4, we subtract the 2x, and we get negative y equals a negative 2x plus 4. Y equals a positive 2x minus 4. They looks like they're the same, so they're both going to start at negative 4. Negative 1, 2, 3, 4. They're going to go up 2 over 1, up 2 over 1, and so on. And these turn out to be the same line. So, if they are the same line, we know we have infinitely many solutions.